Section 8.7, Simplifying and Evaluating Algebraic Expressions. Let's jump right in. Okay, we're going to identify like terms, simplify the expressions, and then we're going to evaluate algebraic expressions for given values. Okay, jumping right in, like terms or similar terms are terms that are constants or terms that contain the same variables like x's, y's, if any, raised to the same powers. Whatever power variable is raised to in one term is raised to the same power in like terms. A lot of these are just going to be live examples just so you can kind of see what it's talking about. So let's jump into one. Identify the like terms in the following list of terms. So let's start looking through here and just see why they say what they say. Okay, notice they're saying 6, negative 10.1, and 0 all like terms because they're constants. There's no variable attached to these. Okay, there's no sort of, basically there's no, you don't see any sort of like sort of like alphabet connected to these guys, or some sort of weird symbol. Notice the 2.2x, negative x, and negative 5x are all like terms because they have a variable x. Okay, and then what it talked about with the powers. You got 3x squared z and 3/4 x squared z are all like terms. They all have the variable x squared z. And yes, you have to count that. Okay, even if you got, now if you just had like one that had a z, well, you'd have a whole nother list of variables with just z. These guys right here, though, are connected. Okay, so let's just kind of think about that as we go through this. Okay, to combine like terms, add or subtract the coefficients and keep the common variable expression. Remember, okay, I know that we're getting a little bit deep into the weeds here, but let's remember, like if you have something like, say, 3x, okay, let's always remember that this right here is our variable, and this guy right here is our coefficient. Probably misspelled that somehow, but I'm your math teacher, not your English teacher. Okay, let's look here. Combine like terms. Well, here this one's going to be straightforward. We've got 8x plus x. Sometimes what I will do is I will come in here and go, okay, yeah, I've got two like terms there. So basically, I know the x's aren't going to change. So I'll come right in here and just do the 10 plus 8, and that is going to give me 18x. Okay, here let's notice that I'll just go and keep this in red this time, save time. I've got the 6.5y minus 2.3. Okay, well, if we do that on our calculator, 6.5 minus 2.3, we get 4.2. Okay, keep the y, but notice this guy here, there isn't anything attached to him, so we have to keep him separate. All right, let's look at this one. Looks a little weird. Yes, I've got a whole bunch of x's on here, but let's remember that I can only add in these guys right there. So you're going to have, remember, whenever you have a coefficient here, there is still a coefficient there. It's just 1. So I've got 2 plus 1, which is going to give me the 3x squared. Well, then notice here I've got a 3 and a minus 1, so that's just going to give me a 2x. Okay. All right, on this one, it gets a little bit different, but notice all we're going to do first is we're going to go ahead and distribute first. Okay, which when we do that, we're going to get 4n minus 28 plus 5n plus 5. Well, noticing now, look, I've got two like terms there because they've got the variable n, so that's going to be 4 plus 5, which is going to give me a 9n. Okay, and then I've got this negative 28 plus 5. Okay, so let's just go and subtract those and keep the larger of the operators there. So it's going to be a negative, so you're going to have a negative 23, and that would be simplified. Now let's look at this guy. Okay, notice I have this a squared here, but I've got an a here, and then I've got a 9. Well, if you think about it real carefully, remember up here, we couldn't do that. So this guy right here is already simplified. Okay, and technically speaking, we would want to get everything in like lower terms or kind of like switched around, but we won't worry about that for right now. Okay, so let's do this last one real quick here. All right, look at this last one. Let's be very careful with it. It's not as hard as what it looks, so don't worry. Okay, so looking at this very carefully, notice I have x plus 3x. That is a That works. Okay, those two are matching. And so does this one on the outside. But let's remember that we kind of need to treat fractions as kind of like a part of our PEMDAS. So let me grab my pen again here. I think it kind of went off on me. Okay, well, let's go and add these. I've got 1 plus 3x, which is going to give me a 4x all over 2 plus 5x. Well, one thing about simplification is, let's remember, I can go ahead and simplify this guy right here, and we know that 4 divided by 2 is going to be 2. So that's going to give me 2x plus 5x. Well, now I've got two common denominators, and then we can have 7x. And that gives us a better answer. Okay, to evaluate algebraic expressions, we're going to combine like terms if possible. Substitute the values of any given variables, follow the rules of ordered operations. Okay, terms separated by plus and minus signs may be evaluated at the same time. Then the value of the expression can be found by adding and subtracting. Okay, let's just take a look. What does that mean? Let's take a look at one. Evaluate x squared for x equals 3 and for x equals negative 4. All it's saying is where you find something. Okay, so let's look at this first one here. I've got x squared. Okay, well, they're saying, what's it going to be when x equals 3? So you go and replace this as 3 squared. Well, 3 squared is the same thing as saying 3 times 3, and so that is going to equal 9. Well, now let's deal with the negative 4. Okay, I've got x squared, so let's go ahead and do the x squared again. This time I'm going to put the negative 4 in parentheses, square it. Okay, well, whenever I do that, I get negative 4 times negative 4. Okay, negative 4 times 4 is 16, and then I've got two negatives, so that is going to give me 16. Okay, pretty straightforward. Let's look at one more here. Let's evaluate this one for when x equals 5. So remember, wherever x is, we're going to put a 5 there. So let's come in here. I'll be writing here a different color, so let's do 7. Oops, write that a little bit better. Let's do, well, 7 times 5 plus 5 times 5 all over 4 minus 2. And then right here, I've got a 5 plus 1. Okay, well, let's start being very careful, very intentional. Okay, notice we really need to go ahead and get this done first. Okay, and we can go ahead and get this done. So 7 times 5, that is going to give us 35. Okay, plus 25. Okay, all over 4 minus 2 times, okay, well, I've got 5 plus 1 here, that's going to be 6. Okay, well, we know this right here is going to end up being 12. Okay, well, let's go ahead and kind of finish this off. I've got 35, okay, plus 25, that's going to give me 60. Divided by 4 minus, well, this right here is going to be a 12. Remember our PEMDAS, we got to go and do our division first. So 60 divided by 4 is going to give us 15. Okay, minus 12, and that is going to give us a 3. So that's what happens. Basically, instead of you solving for x, this is now letting you, it's just giving you an x value, plug it in wherever there's an x, and then just go on from there. Alright, let's do some hawks.